everyone. My talk tonight is titled Using Generative AI and Hybrid Search in the to augment medical data pipelines. Data has become such a big part of our industry and our lives right now, and obviously the medical field is no exception to that. And AI generally has such a big potential to really help us understand and make use of this data. But before we go into that, the theme of this meetup is the AI Renaissance, which I personally love, not just because of the aesthetics. The Renaissance was an explosion of innovation in art and medicine and science, and it's often called the rebirth of humanity. And, obviously our views of the past are a bit skewed, but the Renaissance, as we see it, was really this focus on creating something more human for the better. And I really truly love this idea. There's so much potential with AI today to create possibilities for change and for good and for innovation. And I'm truly excited to see what we can build with the tools out there today. So hi, everyone. Philip introduced me a bit, but I'm Victoria. I'm currently a machine learning engineer at Weeva on the developer growth team led by the one and only amazing Philip. Academically, I studied and did some research in the biomedical engineering fields before eventually getting my degree in linguistics and taught myself programming somewhere along the way there. And I started working in Explosion and fell in love with NLP and the tech industry. And then I eventually moved to Weeva and fell in love with vectors and the tech industry. And now I'm here. So this image is actually made by ChatGPT. I gave it a picture of me and said, reimagine myself in the AI Renaissance. I think it made me a bit prettier than I am, but you know what? It goes. So in the next 20 minutes, there are three main things I'm going to talk about. So firstly, I'm going to go talk about AI native tools and applications and where this is a bit different from traditional structures that we see often, and where AI native tools can really make a difference. So secondly, I'm going to take a deeper technical dive into three features of Weeva 8. So the modular system, generative search, and hybrid search. And then thirdly, we're going to take those three concepts and look at how they might provide actual real-world value against some AI medical use cases. And of course, a demo of a totally cool application, Health Search, that Edward built. But before we talk about AI, I wanted to give a basis into traditional data management. So data is important, obviously, but how you store that data is arguably even more important. So traditional data structures like spreadsheets are often called structured data because the data stored in tables and lists often has a very structured format. But unstructured data, like lots of text in documents, PDFs, videos, images, audio, it's a lot harder to organize into these structured table formats like a spreadsheet, and then even harder to use to provide value in real life use cases. So vector databases are a way to organize this information in a way that makes search and retrieval easier for types of AI use cases. So like retrieval augmented generation or semantic search, all these hype words that we're seeing around everywhere. And by turning these data into vectors, we can apply this relational structure into the storage space, allowing us to use and build applicational useful pipelines with the data. So Weeva is an open source AI native vector database, and that sounds a bit fancy, maybe a bit marketing-y, but what it really means is that we're built from the ground up with AI applications in mind, specifically tuned across all of our features to handle things like generative AI, scalable database, database security, and all those features that allow users to handle large amounts of unstructured data, and also handle the specific types of use cases that come with using this data. So I can give you so many examples of all of this, like our HSW vector index that's custom built that doesn't have the limitations present in some other open source vector index techniques, or our AI ecosystem integrations, everything from Llama Index, Cohere, OpenAI, blah, 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 super easily exchangeable within our database, to our enterprise-ready features like multi-tenancy for security and isolation, product quantization for memory saving, node replication for zero downtime processing. So being AI native is not just something we say to get a green check mark. We've really thought about the best ways to implement all of our features in order to make sure that our customers can build applications easily and at scale without sacrificing on customizability or functionality. So looking at the list of all the databases out there kind of feels like when I was young and I went to our garage and I found a toolbox with like 20 million wrenches of different sizes in it. And I was like, what do you need all these wrenches for? But when you start to look at the things you're trying to build, you're going to realize that different applications require a different set of tools. And using the wrong set of tools will be, at best, inefficient and most likely just not work entirely. And it's not that hard to build a cool prototype nowadays. There are functionalities with tools that make this easier, such as like a modular architecture for fast iteration and testing. But where a lot of the struggle comes from, where we see a lot of our customers struggling, is moving an app from a prototype setting into a production setting. And now you're dealing with much bigger, much harder challenges like scaling and security and monitoring, all the boring stuff. So now not only do you have to find a tool that can help you easily build and iterate on your initial idea, but it's also important that it can carry you into a production level setting. And this is where AI native vector databases play a huge part in building AI applications. They're the right size wrench because they were specifically designed to be that. So there's also this idea of ease of use versus customizability that I'm kind of in love with. If you take either one of these ideas on their own, they're not that hard to design a tool around, right? If you tune a tool specifically for ease of use, it's going to come with a set of preset out of the box functionality where the users can hit the ground running with something that automatically works. However, most cases you need some level of customizability. So there's not really a good one size fits all solution. However, too much customizability and you're giving users a bunch of parts and a long and confusing instruction manual, and that's going to take a very long time to set up and test. Where the true magic comes in is really balancing these two. Having an out-of-the-box solution that can make prototyping and testing easy, while also still providing control over the defaults to further customize it to your specific use case or even level production. And this is where the modular system is super valuable. So it really allows you to have this level of ready-to-use out-of-the-box functionality while still making different parts interchangeable and customizable. So our Vectorizer models are an example of this. We're actually vector agnostic, basically. So there's kind of 3 different options for vectorization. So you can upload your own vectors if you wanted to use your own model and didn't want to give us any raw data. You just upload the vectors and that's it. You can use an open source vectorization model from Hugging Face, for example, that runs directly alongside your data and downloads and vectorizes things. Or you can use one of our built-in provider integrations like AWS, Cohere, OpenAI, blah, blah, blah. There's a long list. Basically, we don't care how you do it. We just want the results. And this is really made all possible by having a modular system. It really allows a clear set of easy to use out-of-the-box functionality, defaults, while still being completely customizable. It allows you to easily build that first iteration of a prototype, I don't know, using a lower cost model, and then further update and customize it as your use case grows, maybe moving to a more advanced or specifically trained model. And because we integrate so well into the AI ecosystem, these are all super easy to exchange. So in Weeva, you can also interchange different search types depending on your needs. So one of the most powerful search types is hybrid search, which is the combination of both vector search and keyword search. Vector search has created this explosion of exciting new possibilities nowadays. By being able to understand the meaning behind a user's query and match it to documents that have similar meaning, a lot of the challenges with traditional search was overcome. There aren't the limitations with needing the exact right keywords in the query, or even things like typos, or it allows us to better handle AI use cases like chatbots and stuff. But keyword search still has some of its strengths. Sometimes you really care about that exact match in the response, and it can still better handle things like short queries, technical jargon, or queries outside its training data. So hybrid search is cool because by combining both vector search and keyword search into one solution, you kind of get rid of all the drawbacks of either system and maintain all the benefits. So in Weeva, both vector search and hybrid keyword search are run simultaneously behind the hood. And then the best results from both are combined using a fusion algorithm. So if vector search were to fail, not return the best results, keyword search would be able to pick up the best results, and vice versa. So this means you don't need to know the magic perfect words to get the best response, but you can still get some of the benefits from both systems. Okay, and then Weaviate. This is a vector search query. Watch here. And then that's a keyword search query. That's a hybrid search query. So there's one thing changing in between these, and it's just that little word there. So it's all built in and interchangeable. There's no building your own system. There's no additional code, and implementing this requires changing literally that one word in the query. And yet still, if you required further customizability, you can add things like alpha parameter to hybrid search to weight it more towards keyword or vector search, or change the type of fusion algorithm because it's possible by the modular system. Okay, so generative search. It takes searching even a bit further than hybrid search. So you may have heard of RAG, retrieval augmented generation, as an example of generative AI. This example pipeline of that. So in this pipeline, you have a set of documents in your vector database already. And then you'll take the user's query and use that to search through your set of documents and return the most relevant results, which then goes into your context. So then those documents in the query are synthesized together in a prompt, and then those are given to the large language model to generate then a response for the user. There's lots of cool things this can do over just using like an out-of-the-box LLM like ChatGPT, such as like reducing hallucinations, updating context, or providing specific information that you want the answer to. So normally the code you'd write for the vector database querying part is that, and then you have two other functions for those things. But the cool thing about Weaviate is it's a generative search module, which means this is all done in a single query. So all the additional code you have to write is reduced into one query, and suddenly 3 different functions in one, helping developers write less code. So how are these features like hybrid search and generative search actually going to help out there in the real world? So I was watching this great webinar by my colleague Byron and Travis from Innovative Solutions, and they were discussing different applications of AI native vector database. And Travis gave a super cool example of a situation they had with a customer and how they solved it. I'm going to be paraphrasing here, but basically, the problem starts with the doctor's office experience often being super frustrating. So the patient usually has to fill out this really long, like 20-page form about your medical history, your current symptoms, whatever else is on there. And then they go into the appointment and they sit down with the doctor, and sometimes they ask a lot of the same questions you just filled out in the form. Frustrating. And on the doctor's side, obviously they see a lot of patients a day. They don't have time to go through that 20-page form for every patient. So it kind of creates this lose-lose situation. The patient still needs to fill out the document for the medical records. The doctor doesn't have time to review any of that data, and the data isn't really being used for anything. It's just left. So how exactly did they solve this problem? Well, first they set a vector database, Weaviate, and filled it with information about different ailments specific to that type of office. So the entries would include things like the ailment, the symptoms of the ailment, and different profiles of patients that had come in and been treated with the same ailment before. Then they took in the new patient's information and queried it through the vector database, which then gave a response of a list of suggested ailments that might be wrong with the patient. Then, using the generative search module, they were able to take the patient information and the suggested ailments, give it to a large language model, and have it synthesize kind of a doctor cheat sheet. Just a few lines about the basic patient information, the suggested ailments they should review with the patient, and it reduced the doctor's time to read, and then the data from the patient was actually being used. So this situation kind of avoids all the redundancy of having data and then not using it. And the doctor can really then focus on providing a more human approach, filling in the missing information, expanding on things that aren't clear, and giving the best diagnosis for the patient. Okay, so demo time. So Philip gave a little teaser into Health Search, but this is Health Search. It's a super cool app. And as Philip said, there's a bunch of supplements ingested into a Weeva instance in the backend. And I'd like to point out, not health advice, just a demo. So, but it could be used. I'll explain that later. So let's just type in one of the default queries here. So helpful for joint pain. And here's going to generate. And the first thing it's going to do is it's going to use an LLM to generate a GraphQL query. So you can see here, this is just the regular get our products query, and it's using hybrid search, which means it's using that combination of vector and keyword search here. And then we're also querying with a generative search. So still using the hybrid query, but then we have an additional task for the LLM where it's summarizing the products based on this query, right? So here we have this overall generated product summary. And then here for each individual product, we also have a generated review summary. So this product is highly recommended for mild joint pains. Great, thank you. And then if you wanted more information, you can also click into the product and get all the reviews. And what's cool about this is it's actually highlighting what it's picking up here. So sore muscles and aching bones. Aching bones, joint pain, very similar in our human minds, not similar to a keyword algorithm, but thanks to vector search, we can actually understand that as similar. So that's pretty cool. And what I think is really going to help with this is allowing patients to have more access to information. You know, there's a lot of information out there in the world, and sometimes it can be hard to find it. And then when you do find it, sometimes it can be too overwhelming to actually do anything with. And I think generative search and stuff like this can really help us better ingest and better manage our information, which is pretty cool. Okay, so there's only going to continue to be more data, more information on the internet, more reviews to sift through, more products to look at, and more patients to attend, just more. So making sure we make informed decisions and take advantage of efficient time management is so important, but it's only going to get harder. And this is where I'll end with a broader point, which is AI really has a dual role in information management. So AI can definitely be a part of the problem, you know, spreading misinformation, hallucinating, being used to manipulate, to harm, embodying stereotypes based off its training. But I also think it can really be used to improve certain aspects of our life, making things clearer, faster, simpler, and we can use it as a tool to empower our choices, augment our understandings, and allow us to make more complete decisions based on accessible and understandable information with our limited time. But above all, I think it can be really best about taking away robotic manual tasks and allowing us to have more resources spent being human for ourselves and for each other. So I really like learning about stuff and rambling about it. So if you're at all interested in technical content or have any questions or want to tell me what you're building, connect, drop me a message. I'd love to hear it. And thank you so much.
Ah, wait a second. Questions. Hybrid search. Traditional text search. There. Wait a second.
Sorry. With the generative queries from Weeva, do you have control over which model version you're using? In fact,
Yes, for sure was the answer to that.
so you use OpenAI?
For sure.
Yes, you can use Cohere, Hugging Face, OpenAI.
We have two.
So which model provider you can use for hybrid search or for rec? So there are two separations. For rec, for example, you have a part which is doing you create the embeddings. So there you can choose an open source model to generate the embeddings. For example, Gina has a nice embedding model. Then for the generation, you can also use an open source model like an Llama architecture.
Yeah, so it's the same sort of module system. It's just plug in what you want, provide the key, and then it works.
Yeah. How much control have you got over the actual LLM? Is it quite?
Yeah, so
Right.
Verba, if you're interested in that, Verba uses the generative search and
I use Weeva, so I'm kind of familiar with it already.
Yeah.
I haven't really used the generative bit of it yet. So.
Yeah, so Verba has options for like GPT-4, GPT 3.5,
Yeah.
Cohere, and something else, sentence transformers, Hugging Face.
Yes.
Yeah, so it's just like even in the front end, we have it so you can set it, which is super cool.
And it's super easy to plug in Genome model, but only for creating the embeddings.
Thank you.
Hi, thanks. Question is, how much control do I have over the selection and the ranking of the results within the generative search?
Good question.
Yeah, so we have a ton of also re-ranking models. So it's also in the module system, which means you can plug in any re-ranking module in our re-ranking module. Yeah. So
Erica is
also
currently
full
working on a
control.
re-ranking model.
Yeah, Erica's doing a lot of good content around this, but also full control, and it's just about what's coming in and what's coming out. It needs to match, and then it's good.
But there's also several features in Weeva which making it easy for you, for example, to combine lists from traditional text search and vector search, AutoCAD, and generating these kind of rankings or lists and re-rank them depending on weightiness.
Yeah.
Yes.
Okay, here's another question then. Do you offer keyword search or sparse vector search or both?
So we just offer keyword.
Wait a second. Sparse vector search is not real. Not just kidding.
So we offer keyword search based on inverted index. We're currently doing some research into providing a sparse vector thing, but we don't have it available yet, and we're kind of weighing the trade-offs.
Now you already had a question. we now need to be a bit picky.
Hi there. Getting back to the LLMs, how about self-served models?
For sure. Yeah. It's available for you to, yeah.
So
if you have it available, you just pass it. Maybe you see me after and I can look it up for you. I think probably you would add like a file path or something, but I can find it in the docs for you pretty easily.
So you can run it in a VPC in AWS and Google. It's available over the market store, market store, and you can, I mean, serving your own model, in the end, you need to take care about the infrastructure. Or you're having own distributed server architecture and running fast API as an endpoint, and the fast API endpoint is serving the language model. More? Yeah.
I would say 2 more questions and then we need to move on.
Hi, would it be possible as a user to sort of do a takeout of my data and bring into somebody else using this database?
Yes, it's definitely possible because you're talking about Pinecone. They are storing you in. So one more question. A long way. It's worth it. Oh, great. Hi, Emma.
Thank you. I'm just curious if you guys spend any time evaluating different methods of search, and if so, how you do that.
You mean like keyword versus vector versus hybrid?
Yeah, like in machine learning, you would always have an eval set, right? Just to see like if what you're doing works. So do you do similar things when you're comparing different methods for vector search or keyword search, et cetera?
Yeah, we currently don't have any like public benchmarks coming soon,
Okay.
but we do a lot of work internally to evaluate these systems, and we're also constantly working on improving different parts of it, right?
So there is something.
Yes.
Cool. Thank you.
And Leonie is here. She had worked on compare or evaluating and benchmarking retrieval techniques. So this is also related because in the end, this is some kind of a ranking you're getting back, and several other metrics. She's here later on. Okay, that was the last question for this talk because we want to hand over